Every day we are writing so many codes. All those codes working perfectly on local. When we deploy those codes on server, on production, that start giving you a memory issue, that start giving you a performance error. And it is possible that, that is because of your CPU start catching fire, right? And you start worrying, you start investigating and you still have trouble to fix all those issues. But now we don't need to worry about. We have something called Visual Studio Performance Profiler within our Visual Studio, right? So be happy, and today video I will show you how we can analyze and fix high CPU usage. That will save you some of the CPU burning, right? Okay, so let's go ahead and let me show you that tool. Let's go to Visual Studio. So this is one of the project that we have. The name is Performance Check Project, right? Right now, if you see, there is only one class, which is program default class, and we have just a main method, and we don't have any business logic, just console.writeLine, right? Now, so there is a very nice option in the Visual Studio. If you go over debug, there you see something called Performance Profiler, right? So you can click over this, but before you hit this button or this option, you have to make sure your application is in release state, because it won't work over debug. It will work, but it won't give you the precise data, the accurate data. So let's set it on the release mode, and now say go to debug, say performance profiler. Okay, here you go. So we have everything set, and I'm collecting the CPU usage, right? So let's collecting the data. It will take a couple of seconds, and then it will show you the report. So it opened the this console window that says it is collecting the data. Okay, so here is our report ready. So this is the graph on the right side that you will see. So we don't need to worry about this graph, but this is all about infrastructure. Whatever infrastructure usage for this project, this application, it shows you that report. If you see kernel, that is operating system, input output, just-in-time compiler, your networking like Wi-Fi or other path, and your files, right? So how much these things takes. Okay. So what important here is we have like top function and hot path. So both of them, tell us that what our application is, how much memory it is taking, how much CPU usage it is taking. So this unit that you see, this is in milliseconds. So it says external code is taking 83 milliseconds, right? And similarly, the other codes. So this is exe file of your project which is running. So it says it is just taking 1 millisecond. Similarly, the other exe which is required to run this application, right? So those are the data we have. Okay, so what is total CPU and what is self CPU? So Microsoft has some formula, right? So basically, let's don't jump into that deep. So the overview is total CPU means, every function is calling so many, different functions, right? So that is the total CPU. So one function, the main function, which is calling, 4 different function. So this record is sum of all those functions, right? And self CPU is, if you exclude that business logic, how much time it takes. So how much time it take to run its own method without any logic, right? So that is the definition of self CPU and total CPU. This will show you in percentage, and this is your milliseconds. Cool. Okay. So right now we don't see anything specific 83, 1 millisecond, 55 millisecond, 55 millisecond, 54. So it looks good, right? So let me show you other data that we can see. If you go over here, open details, so you will see this nice window. So it says external code. What external code is? External code means, the DLLs, anything which is required to run this application, which is required to run your application, those codes are being called as external code, right? Okay, so if you click over here, you will see, this section, this current function is talking about what are the inside function within that, and it shows all those records here. and this is calling and this is called, right? So it give you where it is being called. So it says 55 millisecond, 55 millisecond, and if you click on function body, it will give you those records. Right now I don't see anything. Why? Because these are like DLLs, right? Okay, so this is our main program. So if you see now, the function body of this current function is this. It gave you the exact line, right? So what it says it took only 6 milliseconds to execute, right? And that is the whole climb in this particular line, right? Okay, so this is one thing. Now let me show you. Let's do one thing. Let's increase the load and let's then how the report would be. Let's create one class and name it with load CPU usage. Add let's make it public class. Create one method over here, void, and say increase the load. Okay, increase the load, and let's put some pressure on our CPU. How we can do that? We can write some program, let's say one boolean, and make it keep running. So basically we will create one infinite loop and put some load over my our CPU. So let's set it diff true, and we can say here while this keep running is true, just print something, maybe date time. Yep, let's print date time. Okay, so let me rebuild if okay. Yep, I should rebuild first my project. Okay, it is good. Let's try to generate some report now. I mean analyze this now. So go to performance profiler. Yep, say start. It will take a couple of seconds. Okay, so now it is loading. It is collecting the data actually. Okay, so we have data ready. So I don't see any difference. I don't see my function over here. I only see that program class, right? And this main method. Okay, so I don't see that thing. And why? Because we have created this class, yeah, but we are not consuming this class. So that means it has no use. And that is the reason, it is not coming in the report, right? Okay, so let's do one thing. Let's open our program class. Let's close one of the window, okay? And over here, say create object of our class. Say, okay, CPU and this, right? Okay, so I have to add namespace here for sure. I don't see the option over here. Okay, so let's see. Okay, so that means we are doing something wrong here, or maybe this is not the right class, or this file is opened before this demo. Let's go to exec. I don't see that for some reason. It's okay, let's go ahead and we will see what issue we have, or maybe let's add a namespace. Yeah, namespace is missing. Let's add that manually. Okay, it is still not happy. That's fine. Just compile our method. Maybe this is there is some issue with my editor. Let's say build and let's check what happened. Okay, all build. I think this is just stuck somewhere. Okay, so let's go ahead and try now. Debug, performance profiler, start collecting the data. Now I'm expecting something. Do you see there's some difference? Before it was taking a couple of seconds. Now you see it has been 10 seconds, 12 seconds, and it's keep increasing. That means it needs more time to collect those data, right? The only reason is this is an infinite loop. It is never gonna end. That is the only reason. No worries. Let's stop it manually, and then we will see the report if we have the different result or it's still the same. Ooh, here you go. So you see now we have our function and it says it is taking 450 milliseconds before. And let's see the program class. Okay, let's go to this window. Let's analyze, where is that? Okay, so system date time now says 450 milliseconds. This is executable file. It says 9132. And this is my programming. It says 8427. Before it was only 6 milliseconds if we remember the report, right? So this is how whenever you are working on any applications, you guys can go ahead, debug and start performance profiler, and it will give you the report, which function, which module, you have different filters. Caller, callee, this will give you the same window that we had before, but it will give you all the details, which function is taking more time. So when there is some issue with my logic, right? There is some issue, with this function, which is taking more time. You can go ahead and, start making plan for that function to optimize. I hope that works. Okay, so this is one way, and let me show you the other way. So let's save it. And this process was completely dependent, you have to set it as a release. But now what I will do, I will set it as a debug. So there is some nice option provided by Visual Studio, and that is something called Diagnostic Tool, right? It is similar to that, but only difference is it works in build mode. No, sorry, it works in debugging mode, right? Okay, so let me show you how it works. So to check your collecting the CPU data, make sure you are making your breakpoints. If I wanted to test particular this function, I have to put my breakpoints over here, and then finally I can see how much time it is taking, right? So let's say execute. Okay, so now you see Diagnostic Tool is showing me something. Over here I need to say record CPU profile. Okay, it is already running. Select a range time to blah blah. Okay, let's see if there's something else. Okay, it looks cool. Let's go ahead. I will put something here. Okay, so it start collecting data, right? Okay, so you see all the look and feel is same what we just talked before in without debug mode, right? In the release mode, this release. So it gives you the same look and feel, same way of showing you the report, but for that particular time, right? For while you are in debug mode. And let's say if you put your breakpoint here, and let's see what it says. For sure it will give you some exception, right? Because it is keep running. Now let me put my breakpoint here again. See, it start collecting the data. Yep. So this is one of the strategy that you can use within Visual Studio to detect which function, which code, which line of your application have some issues, and then you can start making plan for the optimization.